Good afternoon, everybody. My name is Vineet Tyagi. I'm going to be talking about a subject in the enterprise data space. Basically, the logical data lake model, or how do you build a data fabric that can drive you from taking the data that the enterprise has and possesses, unlock that as an asset, the analytical assets that you possess, and how do you drive user adoption and business value from these data assets that we have. It's a 40-minute session. I have a bunch of slides which are going to be more informational, a little abstract. Some of them talk about the technology, architecture, patterns, etc., but may not have that much of detail that some of you would like. So please feel free to stop me after the talk, and I'll be happy to talk to you on those specifics, or stop by our booth and catch me there. I'll be happy to talk about those also. So before I begin, let me tell you who we are. Impetus is a big data focused, a big data products and solutions company. We have been working with Fortune 500 companies and helping them on their big data journey since the last 10 years. And folks, that's real. I mean, I've been with the company for the last 11 years. So some of you might be thinking, hey, Hadoop has been in existence for the last 10 years. Is that how long you've been working with big data? Yes. Our first project with Hadoop, even before Cloudera was incorporated, was in 2007, with when Hadoop was in its infancy at, I think I recall working with Hadoop 0.12 version. So since then, we've been looking at use cases and looking at how we solve different problems for customers. In the last 10 years and now, what are we seeing with our customers? So just relating some of these challenges and some of these experiences from the field, what we are seeing today in the big data world, working with customers, working with several people, is that across the board there, IT and people who are working with big data, business users, are seeing fast changing analytic and reporting requirements. So you have to be fairly agile. It's not a cast in stone requirement. The moment you're building things, you have to be very agile and nimble in delivering use cases, refactoring them, and have that agility also to take it into production and refactor things as they are in production or as they are in motion. There's still a lack of end user service, self-service capabilities. So users are wanting now, they're power users, there are more educated users who want to work with data themselves. They have the skills, they have the knowledge, and they want to work with data. Everybody is pretty informed these days. Everybody knows about the power of big data. And one of the things that the promise of big data has been that you would put the data in the hand of the end users. So there's a tremendous lack of self-service capabilities, and most of the enterprises we are working with and for are focusing on this as a challenge to solve. There is a need for better collaboration and agility in working with data, kind of that relates back to the self-service capabilities I'm talking about. But there has to be better collaboration for the enterprise to realize that benefit and deliver it for the end users. That has to be an effort which breaks down the silos of operations, whether it's between IT and business users, whether it's between different LOBs, etc. That needs to be broken down, and there has to be more agility in dealing with data. We're also seeing that data in silos is making it difficult to get close to customers. And additionally, while you have the lake and you're gathering new sources of data or rewiring the information plumbing that's going into the lake now, traditional data sources still remain important. The promise of data lake, when we all began working with Hadoop in 2011, or when it began a little more mainstream in 2012, was that there will be an enterprise reservoir, there would be an enterprise data lake that would contain all the data assets that are there in the enterprise. And that would be the trusted data source for the enterprise. Well, that's not happened, folks, as yet, as many of you know. The enterprise data sources, the traditional data sources still remain, and we'll talk about some other challenges that are causing this. So before I move on, I just want to share some facts that we are realizing. It's kind of setting the message up, why we think the logical data lake model is important, why we think the logical lake is the answer for some of these challenges, and helping you realize the true data to insight to business value, kind of the data fabric. Today, almost for every dollar that the enterprise is spending on enterprise IT or big data, the ROI is about 15%. So that's pretty much that we are losing 85% or 85 cents to a dollar on inefficiencies of data integration or of data loss, or fidelity is not the right, or it's dirty data and you have to spend time and effort in managing that. There is effort being spent in fighting the bureaucracy as well. And the promise of the data lake was that you would not have to do all of these. Another fact is that big data was good, big data was real, but what has happened now is that large enterprises, LOBs are as big as companies. And even division within the line of businesses sometimes are as big as companies. So as Hadoop was evolving and everybody was experimenting with what they can do with Hadoop, there have been a proliferation of fragmented purpose-driven Hadoop data lakes. And what that means is that there is almost not one data lake, there is probably tens of data lakes the enterprise has now. And that's creating even more complication for there to be a single trusted data source that can be treated as an asset by the enterprise. Each one of them could have domain-specific data. They could have purpose-built, ontologies. They could be solving a complex problem only in that LOB. And now I was talking to one of our customers, a fairly large financial institution. It's one of the Fortune 50 companies. And we are undertaking an exercise with them where now we are integrating or kind of consolidating 10 of their data lakes, which have distributed across the different LOBs. They have different distributions. Some are Cloudera, some are MapR, some are Hortonworks, and they have extremely replicated amounts of data. So every data lake has certain data that the other data lake has, and it's a pretty big, messy affair, and there's a lot of redundancy that needs to be eliminated. So this is again one state of the art that thing that we are facing with. This is the new normal. I think faster and sooner we recognize this. This is all of what we're all of us in the IT side of business, enabling the business users and working with big data. This is what the reality is. There is going to be the traditional data sources. Enterprise data warehouses will remain. And now you have multiple of these big data warehouses. Now they could be a lake, one single lake, if you're fortunate, or they could be multiple lakes if you're unfortunate. And if you're really unfortunate, there could be many, many of these lakes, and you have to work with these. The fact is that if you really want to leverage the power of big data, as it was promised, deliver advanced analytics, machine learning, artificial intelligence, all of that needs a lot of data. It needs the complete data, the 360 view of the data the enterprise needs. So now the challenge is, how do we bring all of this together, all these disparate data sources together, and really create a unified enterprise data as an asset that can be leveraged by the enterprises. So what I'm going to be now talking about is how do we solve this problem. So the logical data lake structure, the data fabric, how do you create that? But before I move ahead, what are some of these challenges that you will end up facing when you start with this endeavor of, hey, I want to have everything, all my data assets, and you can consider them to be in EDW, data lakes or wherever they are, right? The reality is moving all of them, it's going to take a long time. It's going to take several years. It's going to take 2, 3, 5 years for all that consolidation or unification to happen. So what are these patterns? What are some of these architectures that we can leverage, and how do we all pull it together? But when we pull it together, we run into these challenges, right? The number one and the topmost challenge is when you bring everything together logically, which is not a single data source, which is not running on one single Hadoop cluster or something else, how do you provide a seamless, complete view of the business data? Because that's going to be extremely important for the business users. How do we take that and make or equip the users with having enough intelligence to kind of discover what is there, use it in a fully governed manner, access it, create new data sets and work with them. So creating this visual way of discovery and doing it in a pretty much self-serve way is one of the biggest challenges that the logical lake paradigm has to face, and we'll have to solve for that. The second is on this data fabric, this has to be a self-serve enablement, a full self-serve enablement of BI. Right from provisioning the cluster, getting the data into the cluster, down to ingesting and transforming this data, to discovering and blending new data sources that may exist, and then using this use case specific data for exploration and creating further insights. The other thing is, as we all know, there is no one SQL on Hadoop or one data access mechanism that can be exposed to really access the data that's there in the logical data lake. Now the logical data lake now is going to be a kind of a federation of data sources which are existing. So how do you make sure that all these use case specific data access mechanisms are supported? Unfortunately, you don't have one way to kind of have one Oracle-like or a Microsoft SQL-like SQL and Hadoop engine that will allow us to suffice all the use cases. So you'll end up supporting, at least from our experience, we think at least 5 distinct type of use cases. SQL type use cases where you're looking at specific querying and reporting, OLAP for fast slicing, dicing, and exploration of data. Data virtualization if you're doing cross joins across different data sources, etc. If you're solving the needle in the haystack kind of a problem for your business users or for customers of the lake, it's going to be more like I need to search and explore. I don't know what I'm looking for. I can't query for it. I'll have to have different mechanisms for searching it. And then there is the you don't know what you don't know. I don't even know what's there, so what should I do? So those kind of use cases are where you have to have the self-service data discovery enabled. And each of these 5 data access mechanisms are pretty distinct and have to be built into and dealt from the data lake. The other challenge that comes up now is going to be, there's going to be data lake, there's going to be traditional repositories, there's going to be the Teradata warehouses and the marts, there's going to be Netezza, there's going to be Oracle, there's going to be a lot of PL SQL, legacy code, pretty trusted analytical assets that have been built by the enterprises over several years of experience. Things that work, power the business as usual, cannot be lost. And just because we have more sources of data doesn't mean that what's working is all wrong and we have to redo it. So leveraging that and figuring out logically all these data assets. Now the important thing is going to be, I have a multi-platform strategy. I have the Oracle, I have the Teradata, I have my Hadoop and data lakes and whatnot. How do I take and create the optimal placement of the workloads? If I have this blueprint of my enterprise where physically I can pretty much move things around, what is it and how can I pretty much decide where should I be placing these workloads? And that might mean that some things move off the enterprise data warehouses into the Hadoop, and maybe sometimes data moves back into the enterprise sources from the Hadoop, and this has to be seamless. This has to be a seamless experience. And one of the last challenges is going to be how do you do all of this in an environment which is fostering innovation? Innovation is the new currency for social, all these citizens, data scientists, the new advanced analytics, machine learning. It's all driven by a lot of collaboration and reuse, both on the data side, which is pretty much called the data democratization. How do you enable that, lowering adoption barriers for the stakeholders? They can find the data assets, they can get what data they want. They don't have to go through a long bureaucratic process that takes months or even weeks to enable them to get to the right data. And we are also introducing a new term. We've started calling it the analytical democratization. As you build new assets, analytical assets, let's say you build a new scoring algorithm, you make that work in R, or it's a Spark Scala code which is doing some kind of scoring, or it could be simply a Hive QL that does some data quality or data aggregation before the data is used for analytics. We have seen across the enterprise that people lose, when they work in silos, they lose the reuse for all of this. So how do you make a very simple, consistent way of creating reuse of whatever analytical assets are being created by the enterprise, right? So publishing and discovery of enterprise analytical assets and ability to reuse them for purposes that other people may have. So both of these are an additional challenge that we are facing, that we've seen that enterprises, when they go on this journey, are going to be facing. Okay, so I'm sure you must be wondering, okay, this is good. Maybe sounds interesting to all of us, but what about how do we get past these challenges? What do we do? So let's start building our logical lake. Like I promised, we'll have the solution, a high-level solution for this. Our blueprint for really a data fabric that works is, at an abstract level, is this. This is the logical data lake. Our blueprint is the model, we call it the modern analytical data fabric. And what you see here is basically an ability to handle all sources of data, whether they're streaming, unstructured, structured, kind of structured, well understood, but still, coming at you in a more, volume and other ways, or there are some external social or different sources of data. Be it whatever, newer sources of data, you need an ability to connect and consume all these sources of data, okay? So one of the best patterns, this is the data fabric that we are recommending, right? You've got to have a way to handle the real-time applications and handle the real-time use cases. And Hadoop is the best repository for cleansing and publishing data within the enterprise. So that is the landing and ingestion zone. The traditional data repositories continue to exist, but become one of the databases that can be leveraged in the lake. You have the enterprise data lake again on Hadoop, and all of this is enabled through a common, consistent enterprise metadata management system that captures metadata from things which are happening, right from the real-time applications to as data is coming in, what traditional data sources or traditional data repositories are doing, to the enterprise data lake. And this forms a basis, an intelligent basis for enabling all type of use cases. This is the consumption side. So ingestion, managing the logical data asset and exposing or utilizing that data for consumption. At a very simple level, this is what we propose, what is our architecture for the data fabric. Now with this, how are we solving some of the challenges, right? So that's important to know. So providing a complete seamless view of business data that can be discovered. So that people can come in, they can identify unknown data, they don't know what's there, so I just go in and I look for, hey, okay, I'm looking for customer data. So the lake or the logical lake can tell me I have customer transaction data, we have 3 sources in Teradata around that, 5 data sets in the lake, which is historical transaction data, I have the profile information, and you can visually discover all of that. And what more would be even exciting, what would be even exciting for our customers would be that if they can see that, hey, there is these scoring algorithms, there is this Hive query, there is this program that enables us to cleanse the data. There is this customer 360 view that can be created by these set of queries or these programs or these pipelines, and all of this is visible, right? And the first question that comes up when we propose this kind of, I call it the limitless discovery, that comes up is, hey, okay, how do you govern all of this? And if you're letting users access all of the data, then isn't that a governance risk? Because there could be some people who may not be exposed to that data. So the distinction here is that basically what we are exposing is the meta information. We are exposing information about the data sets. We're not exposing the data sets itself. So they don't reach out to the actual data. So they can discover what exists, but once they want to access and use it, that has to go through the governance process, right? So just knowing shouldn't be limited, right? I mean, if you know what is there, you can request access, you could enforce certain things and all of that. So that's our paradigm, and that's what we have implemented. So there's an automated sourcing and seeding. That's going to be an important perspective and pattern to build. Consolidation of the enterprise data dictionary is important because there is going to be a lot more information that already resides. So how do you use that and use that or supplement that existing catalog and metadata information that's there? And how do we make this lightweight? So make it easily discoverable but also indexable. It doesn't have to be an MDM solution that's capturing all this information. Well, MDM solutions are good, but you could have social tagging based information that's bringing in more or gathering more social information about how data is being used. And that's turned out to be a wonderful way in some of our customers. They are really innovating where there are data stewards and champions who are running contests and hackathons, and users are kind of getting empowered to tag back whatever metadata, technical metadata is there with usage patterns, with other things they're using it for. And that forms a good supplement and a very for the basis for intelligence of what data could be used for within the enterprise. And like I said, it's not only a data catalog. We can catalog the analytical assets as well. You can have a service catalog which can catalog all the queries, the Hive queries, the Spark Scala programs, and other things that exist. And the other thing is, in this data fabric that we just looked at, the whole data fabric allows you to leverage the EDW, BDW coexistence. So you don't have to fight the battle of offloading, sunsetting, siloing. It's all one data set. It's all one big giant data set the enterprise has. Now we have to figure out how to use them for our benefit. And that means figuring out the right positions for the workloads on the price performance kind of a dynamic. And we've seen this be very successful because that puts everybody at ease. Like there is a lot of fear, there's a lot of uncertainty, there's a lot of confusion. Okay, what should I be running on Teradata and why should I be running on Hadoop? What's my ROI? And there are very specific things that you could run on Hadoop where you can decide that for the price and performance I want to spend on doing this, this is my best platform. And for the price and performance for doing something else, Teradata may be the best platform that provides you the ROI. So having the right position for these workloads to exist is the strategy that's helping us rationalize the placement of workloads. And then it is also kind of creating the right platform for advanced analytics. When you do machine learning, when you do a lot of other things, all the existing data tools like SAS, R, they have connectors to Hadoop now. There's the grid that's coming up. So technologies exist that do allow us to leverage all of this together in a very consistent fashion. So let me now move on to a little bit on the technology perspective and choices, and then come back again to the pattern that we had, the data fabric, tie it all back. So if I look at the architectural patterns, the choices that we'll have to have and implement on the logical data lake, pretty much 7 types of things. And these are fairly well known, patterns that exist. Either it's going to be streaming ingestion, we'll have to deal with streaming ingestion type of use case patterns, or it will be some kind of near real-time event processing with some kind of event outcomes. You want to trigger something, or you want to kick off a processing or a job. The third pattern on the streaming side would be a near real-time partitioned event processing with external context, and I'll talk a little bit more about each one of them, where this basically is when you have to look up some information you can't hold enough in the memory to take decisions on whatever you're doing. And then there is complex aggregations, like machine learning has to happen in a fairly larger batch of data that is aggregated. It can't happen on each one of the data. You can score things on each one of the events and whatever, but if you have to do machine learning or do trending or patterns and other things, it'll have to happen on a little bit more complex topology. You'll have to accumulate data, etc. And then there's more of the streaming plus the batch kind of patterns that will have to be taken off. Of course, the Lambda architecture is one of the patterns that comes up. And then there's pros and cons about, hey, Lambda architecture does work, doesn't work in many of the use cases. So there is another alternative, which is the Kappa use case, and then there is more unification with Spark coming up. So Flink and Spark both enable a good pattern of actually doing batch and streaming kind of together. So the thing is that the logical data lake or the logical lake data fabric architecture I just laid out for you supports all these kind of use cases. It's how you enable different things at different points of time. But the logical data model as a blueprint allows all these things to happen. So let me quickly jump ahead and kind of just talk a little bit more about each one of these patterns and the technology choices, but we'll come back to our main pattern in the end and see how it brings together everything. And I'm just rushing through it, so I do want to leave some time for the questions per se. So like I spoke about, streaming ingestion, pretty straightforward. You have streaming sources of data. You're efficiently collecting or aggregating stuff as it happens and comes in. Emphasis on low latency persisting of events to HDFS. So you're basically collecting things as they happen and put them in. Near real-time event processing. So not only you are now collecting the events, you're analyzing them. So this requires some sort of external action or immediate action to either transform the data or do something with the data. So these kind of use cases, I think the best kind of patterns are there, and I'll talk about technology choices for each one of them also. This pattern talks about partitioned external context, which is more like if you can't fit everything that you want to do, the external information that you need to intelligently decide what this event should be, scored on or could do, you need, some kind of a partitioned context available to your external system that you can reach out into and have quick information that can enable you. So there are different tactics to doing that. You could use keys and other ways to determine partitions. I don't want to go into those details. You could do it with Kafka and other things. So that's the more complex topology for aggregations or machine learning. That's where you're micro-batching things up and applying machine learning things on that. I think the thing is that once you have built up a streaming ingestion pipeline and have a capable way of handling that data and a batch system, you have the technologies, the basic technologies in the stack allowing you to do that. How you're solving different use cases is just a mix of whether you end up using Kafka or a Flume interceptor for low latency ingesting, then whether it's a Storm or a Spark, depending on your choice of what is the timeline in which you want that event to be processed and the SLAs around that. So all of these choices kind of work very well across these streaming sources. Lambda architecture, everybody knows about it. It's got the speed layer, which is the streaming ingestion side. And if you do recall the logical data lake fabric I had displayed earlier, There is that streaming ingest or the streaming applications pipe that was at the top of everything, that was handling streaming sources of data and providing capabilities to implement these sources. That's the equivalent of the speed layer. Then we have the batch layer on the consumption side. That's the servicing layer that provides access to all the data. There are many problems with Lambda architecture that people run into when they start running and using it. And that's more to do with, okay, if you have two paths, data paths within the data fabric, you'll have to code your logic twice to handle that. And that being a big problem for some type of use cases where there are frequent refactoring and frequent changes happening. So that's the Kappa architecture, and that basically ends up replacing the speed. So there is only one path in the data fabric. So all the data is coming in through the streaming source, and instead of splitting it up and putting it in RDBMS for persistent storage, you actually append it to an immutable log that you can then go back and reprocess and all that. So not going into more details around that kind of architecture, but what I'm trying to just summarize here is the different type of choices, technology choices which are available. And also the fact that these are valid choices, and the logical lake, the architectural blueprint I just provided, is going to suffice all these patterns. Okay. So the unified batch and Spring, we have two choices now. Flink is quite capable. Spark is mainstream. It's the best choice available right now, so I'm not talking too much about it. But Flink also is quite capable, a good contender for many types of use cases. Unfortunately, it's not that mainstream right now. It's not taken off as much as Spark has. So if you're looking for good support, Spark has good capabilities for all types of unified operations. It can't do near real time, so that's the next thing. So how do you decide what should I be using? What's my choices? How should I be deciding that? And that's, in our opinion, that's pretty much based on, in our experience, based on what do you want to do, okay? The SLAs, what is it that SLA that you're going to achieve? If you're looking at anything below tens of milliseconds, let's say 50 milliseconds, then these are just guideline factors. You could put in your numbers here, but if it's, let's say 10 milliseconds, you'll have to do some custom coding. You'll have to write something if you need something that fast and to be processed that fast. If you have less than 500 millisecond, let's say 180, 200 millisecond type of response time requirements, you have Storm, Flume interceptor kind of thing. If you're looking at anything above that, you have Spark, Trident, Spark Streaming, Impala. Many of these could be use case dependent. You'll have to try out options. And then you go into the batch world. Anything above 30 seconds and above that goes into the batch world. And you have the Impala, Spark, Tez, I1 Tez option, which is there for you. So that's a pretty rough guideline for technology choices. Now, having talked about all these things, I'm sure I kind of rushed through things, but this gives a good perspective of I talked about what are the challenges and how does the logical data lake or the logical lake and the blueprint we provided, how are we utilizing that in solving the problems for our customers, implementing with our customers a brand new strategy, almost the next generation version for big data within the enterprise. And we are enabling that. Impetus, like I said, has products, so we have products that are pretty much enabling and making it simple for an enterprise to implement this architecture or this blueprint for enterprise benefits, creating this data fabric that can take or reduce, I would say reduce time from insights and create a rapid user adoption and business value. All seamless products. If you've not already stopped by our booth, do stop by. We do have this, what we call a data blending solution. We have enterprise metadata management as a solution, Kairos Insights. We have Stream Analytics, which allows you to build and handle all these kind of streaming patterns and streaming use cases I talked about. And then on the right positioning of use cases, this in the enterprise today can only be achieved by manual migration. Let's say, for example, if you decided on unlocking some Teradata analytical thing that you have perfected over the last 5 years, and you want to move it over with new data on the new data lake, it's always a manual migration that's your option. We have a pretty magical solution, as we call it. At a press of a button, we can analyze your Teradata logs, we can analyze your EDW logs, and we can figure out what could be offloaded. And not only that, we can actually do the migration. We can do the forward engineering of the code. We can analyze the SQL code, BTEC code, PL SQL scripts, and generate native HiveQL, Spark SQL, and can make them work at a press of a button on the lake. So this is pretty much a reality. We do make it real. We are helping customers realize all these benefits. So with that, I think we do have 5 minutes. If you have questions, I can take your questions. I would assume I did a good job then. Anyway, folks, thank you very much. Thank you.